Okay, so now we'll review the questions in module 1. With the MAC address, we know that a MAC address is typically 48 bits, right? So we have 6 bytes. The first 3 bytes uniquely identify the manufacturer. We call it as the organizationally unique identifier (OUI), and this second 3 bytes uniquely identify the network interface card produced by that manufacturer. Okay, so we put everything the both together, the whole 48 bits or 6 bytes becomes globally unique. Okay, so now we need to use the first byte um, to identify whether it is a globally or locally unique MAC address. So globally unique means, of course, is OUI enforced, and whether it's a unicast or multicast. Okay, so if the least significant bit within the first byte, if this bit is a 0, it indicates a unicast. If it's a 1, it's a multicast. If the second bit is a 0, it is a globally unique OUI enforced address. And if it's a 1, it's a locally administered address. So let's see what we have here. We have here 0A. So this is a byte. Each digit here is a hexadecimal digit. So if you represent 0A in binary, 0A in binary is 0, 0, 0, 0. A is 10, 10 is 1, 0, 1, 0. So you have a 0 here, so it indicates it's a unicast, and it's a 1 here, so it means it is a locally unique unicast MAC address. Okay, and we have 4, 9, so this is a locally unicast MAC address. Then you have 4, 9, 4 in binary is 0, 1, 0, 0, 9 is 1, 0, 0, 1. So it is a 1 means it's a multicast, and a 0 means it's globally unique. So it's a globally unique multicast MAC address. Okay. Now, what's the difference between unicasting, multicasting, and broadcasting within a network? You should know this. Unicasting is sending from one machine to another machine. Multicast from one machine to a subset of machines. Broadcasting means sending from one machine to every machine in the network. Okay. Now, class A networks. Okay, so this is the numbering number of bits. So IP address is 32 bits, right? So for class A networks, the first 8 bits is the network part, and the remaining 24 bits is the host part. Class B, the first 16 bits is the network part, and the remaining 16 bits is the host part. For class C, 24 bits for the network and 8 bits for the host. Now, class A, the first bit is fixed to be 0. So you really have only 7 bits to play with. Then for class A, all those 7 bits cannot be 0 or 1. So which means you rule out the possibility of all 8 zeros or a 0 followed by 7 ones. So which means you cannot have like 0 followed by 7 zeros or 0 followed by 7 ones. So you rule out the possibility of having a 0, or this is 127, right? So the class A, the network part can go only from 1 to 126. Okay. Now the host part, we know that all the bits in the host part cannot be all zeros or ones to indicate a unicast address. So that's why we have 2 to the 24 minus 2. Okay. Now for class B, you have the first bit is fixed to be a 1 because class A, the first bit is 0. So for class B, the first bit has to be a 1, the same way for class C, D, and E. Now the second bit is fixed to be a 0 to distinguish it from the other classes. So the other class have a 1. Okay. So you have basically the 16 bits, the first 2 bits are fixed. So you have only 14 bits that you can play with. So you can have 2 to the 14 class B networks. And in each such class B networks, you can have 16 bits for the host part, so you can have 2 to the 16 minus 2 hosts. Now for class C, you have the first bit is a 1, the second bit is a 1 because to distinguish from class B. Then to distinguish from the rest of the classes, you have the third bit in class C IP address to be a 0. So which means you have the first 3 bits fixed within this 24 bits for the network part. So the you can really have only 2 to the 21 class C networks. Okay. And within those 8 bits for the host part, you cannot have all zeros or ones, so you have to do the 8 minus 2 host per class B network. Okay. Now identify the class of the following IP addresses. You have 143. So now you should also note that with the first 8 bits, right? You can have class A go from 1 to 126. Class B, because the first 2 bits are fixed to be 1 and 0, right? So you can have the remaining 6 bits to be zeros. So this is 128. And the first 2 bits are 1 and 0, then the remaining 6 bits can be like this. So this could go from 128 to this is the 3063, so 191. Okay, so that's for class B. Similarly, class C, the first 3 bits are like this, so the remaining 5 bits can be like this. So this is 192, and then the remaining 5 bits can be like this, which is 31, so 223. Right? Then class D, you can go the first byte from 224 to 239. Then class E, which is not really used, okay, 242, 255. All right, so now this shows that 143, this is a class B, because this is the range 128 to 191. Then 18 is a class A, 212 is class C, then 224 is a multicast. Okay, so what's the difference between a direct broadcast IP address and a limited broadcast IP address? A directed broadcast IP address is used to broadcast a packet from one network to a remote network. So if you want to send, say, from I used to always use this kind of figure, right? So if you want to send from this network to all hosts within this network, then I can use the broadcast IP address to be what? This is a 190.34 network, right? So I can use the broadcast IP address to be 190.34.255.255. It's a class B network, so the 16 bits per host part has to be ones for a broadcast IP address. So if I want to send from 143.132 this network a packet to this, all the hosts within this network, I can use this as my directed broadcast IP address. Whereas a limited broadcast IP address is simply all 32 bits to be ones. So this you can use to broadcast only within this network. Or any network, a host can send to this broadcast IP address to send a packet to all machines within that network. So using a limited broadcast IP address, you cannot broadcast to some other network. Okay? You can broadcast only within the network. So that's the difference between the two. So now what's the subnet mask for a class A, class B, and class C IP address? So for a class A, you have the first 8 bits for the network and the remaining 24 bits for the host part. So you should have 8 ones followed by 24 zeros. So that makes it for class A, the subnet mask is 255.0.0.0. For class B, the 16 bits for the network parts are 16 ones and 16 zeros. So it is 255.255.0.0. Class C is going to be 255, 255, 255.0 because we have 24 bits for the network part, so 24 ones followed by 8 zeros. Okay, so now consider the following IP addresses, and we want to find out whether what class it is first, because you're in this example you're doing class-based IP addressing, and we want to find out whether it's a network address, broadcast IP address, a unicast IP address, a multicast IP address, or a private IP address. All right, so this is 143, so it's a class B. So class B, you have 16 bits for the network and 16 bits for the host part. So that's the host part. The host part is not all ones or zeros, because if it's all ones, it would be 143.132.0.0. If it is all ones, it will be 143.132.255.255. So it's neither of them. So it's a class B unicast IP address. Now what about this? 229 is a multicast, by the way, right? Then 16.1.255.255, you see here 16 means it is a class A. So class A, the first 8 bits are for the network part, the remaining 24 bits for the host part, which means these 24 bits represent the host part. Okay, so as part of the review for your, okay, so these 24 bits represent the host part, and not all of them are 1. You see here it has to, if these 24 bits have to be a 1, so which means if it is 16.255.255.255, it will be broadcast IP address, but we don't have like that. So it is a class A unicast IP address. And 10, you should know the range for private IP addresses. Okay, so these are the ranges for private IP addresses: 10.0.0 to 10, the whole range, and 172.16 to 172.31.25, and then 192.168 to 192.168.255.255. So let's continue here itself. You have so 10.1 is a private IP address, 172.18 against a private IP address, 202.14.12.255. 202 is a class C, and you have 255, the last 8 bits for the host part is all 1, so it's a broadcast IP address. Then 156.25.32.0, 156 is a class B, so expect the last 16 bits, the last 16 bits should be the host part, right? So if all the 16 bits are 0, then it is a network address. But here we have 32 dot zeros, not like all of them are zeros, so it's a unicast IP address for a class B network. Now 202.45.69.0, so it is class C because we have 202, then which means last 8 bits for the host part, which is all zeros, so class C network address. Now, with a private IP address, you cannot route a packet directly to a private IP address over the internet, because private IP addresses are not publicly routable, because private IP addresses are reused. So you may have a machine in one private network have 10.1.1.1, some other machine in some other network organization network can also have the same IP address. So if you want to send a packet to this 10 machine, how would the routers in the internet know whether they have to send it to this network or the other network, because both machines have the same IP address. So that's why private IP addresses are not publicly routable. Okay, stop with this here.